Hello students, my name is Abhishek and from today we are starting CSAT through PYQ series. As we know, CSAT is becoming quite a challenge for many of the students, primarily because we are approaching it in a way that is not intended to be. So in this series we shall see how simply we can solve CSAT questions without using many formulas. That would be our goal, that we don't want to use many formulas. We just want to stick to very simple facts, logic, and we just want to apply those simple facts to solve the question in as little effort as possible and as quickly as possible. Of course, some of the questions might take some more time, some questions will take very less time. Some of the questions may not be apparent immediately in the examination hall that this is the method you have to apply, but some others it would be very apparent. But I shall tell you what you could do in examination hall as well. So today we'll starting with arithmetic 1. In this we'll primarily have questions from place value system, odd even integer like number system, and basic mathematical operations like addition, subtraction, multiplication, division, and we shall see how many questions have been asked from this particular section or this very basic topic which we study in like 5th, 6th standard also. So let us begin. And of course, arithmetic is perhaps the most important thing that has maximum weightage if we consider past few years of UPSC CSAT papers. So we shall divide arithmetic PYQs into 3 lectures. Today is the first among them. See the question, this particular question, we are given 5 positive integers PQRST, and 3 are even and 2 are odd. That is the information we are given, but they are not in order. So any 3 could be even, any 3 could be odd. That is the meaning. And we are given 2 statements. There are 2 distinct statements. So in essence, this one question has 2 sub questions. So of course it will take more time because there are 2 questions that you need to attempt. Now look at here. Let us first focus on the second statement. We have 2p, 2r and 2s. All of them are even number because 2 into any integer has to be an even number. So this particular quantity is nothing but some even number plus q plus t. So nature of this number would be determined by q plus t, and all we need to know is the fact that even number plus even number is even number plus odd number is odd number, and odd number plus odd number is even number. That is the only fact we use in this particular question. So here we are even number, and nature of this entire quantity would depend on if this number is even or odd. Now from the given thing, can this number be odd? Yes, if q is even, t is odd, or t is even, q is odd. Both are possibilities. And can this number be even? Yes, if both are odd or both are even. So this particular quantity can be even or can be odd, but we cannot say it is definitely odd because it can be even. So this statement is false. We are only using this particular fact, nothing else. And second, or what you can do is take any 5 integers 0, 1, 2, 3, 4. 3 are even, 2 are odd, and you just try which particular thing. So there is this even number and then q and t. Now q you can take 0, t you can take 2, so you get a even number. If you take q as 0, t as 1, then you will get odd number. So you can't decide what this particular quantity would be. So this is a false statement. Using values also you can do in examination condition, you can put the values as well, or you can do this way as well. Now let us look at the first condition. We have p plus q plus r minus s minus t. We can write it as p plus q plus r minus of s plus t. So here we have one quantity, here you have another quantity. Now we have 3 even numbers, 2 odd numbers, which we don't know which are even, which are odd. So we'll take cases. There are these 2 s and t, there are p, q, r. So in this s and t, both could be even or one is even, one is odd, or both are odd. These are only cases possible. So if both of them are even, then we can have one even, two odd. If one is even, one is odd, then we have two even, one odd. And if both are odd, then all three are even. Because it is addition, order is irrelevant. We can have even plus odd, odd plus even. Everything will give you same quantity and same evenness or oddness. Now in this case, you have 3 even addition and odd plus odd is even. So addition of 4 even numbers would be even. Yes, this is even, and odd plus odd, again even, odd. So this is even number minus odd number. Sorry, even number minus even number would be even number. Here we have odd number, here we have odd number, so odd number minus odd number is even number, and here you have even number plus even number, this is even number, and this is even plus even number, so even minus even is even. So in all the cases you have this quantity as definitely even. Okay, so this statement is correct, this statement is false. That is why we have answer as 1 only. Now in examination condition, this question you could have left alone because it is time consuming. It is not difficult, but it is time consuming. Why? Firstly, there are 2 questions. In one question there are 2 questions hidden, and to get the first answer definitely you need to make cases. Or if you want to solve in examination condition, what you can do, you can take these values and then try to play around with it. But if you are taking values, take at least 2-3 cases such that, so you can take PQ as 0-1, ST as 0-2. So ST you can take both as even, one odd, one even, both as odd. So you have to play around with a little bit. So 2-3 cases you should take, and then only comment on the answer if you are using specific values. But something that you can take a note of is, this is not a difficult question, albeit a time consuming one. Let us move ahead and we'll come to easier questions that were there in this particular year's CSAT. See, this question number 2, we have this number xyz, and we want to comment on if this is divisible by which of these numbers. Now first let me show you how you can do it using simple place value system. Place value is something that we have learned in our school days. Basically, if you have any number, let us say 101010, what you can do, or let us take smaller number for you to just understand, 23, you can write it as 2 into 10 plus 3. Place value of this 2 is actually 20, and place value of this 3 is 3. This is units place, this is tens place. Similarly, if you have 2, 3, 4, you can write it as 200 plus 30 plus 4, or you can write it as 200 plus 34. In multiple ways you can write. Fundamental thing to note that here place value is 200, here 30, here 4. This is the place value system in decimal systems that we have learned in school. That is what we will apply in this particular question. So you have this particular number, let's see, xyz. You can note that there is symmetry about this particular after 3 digits. So after 3 digits numbers are repeating. So we can write xyz 000 plus xyz, which is same as, you can write it as xyz into 1000 plus xyz. You can take xyz common, xyz into 1000 plus 1, which is equal to xyz into 1001. Now once we have this particular number, that there is a 3-digit number multiplied by another 1001, and we want to comment on whether this number is divisible by 7, 11 and 13. Now we just try and divide. If this 1001, it is divisible by 7, yes. It is divisible by 11, yes. It is divisible by 13, yes. You can check using long divisions. It will not take much time, and you can say that 1001 is divisible by all 3 of them. So this particular multiplication, it will also be divisible by all 3 of them. So answer is 7, 11 and 13, all of them. all we have used here is place value system. Again, in examination condition, this particular trick or place value division may not be very apparent to you, but what you can do is you can just take any values. And actually I had covered it in the class that any 3-digit number multiplied by 1001 will be something like this, will be a repetition of the 3-digit number itself. But even if you don't know it, you can just take any number 123 123 and check. Then you can take one more just to be sure, 567 567. If you want to take simpler, you can take 124 124. Check for this, check for this, and because of this fact, it will be divisible by all three, and you can solve this particular question. Let us come to next question. What is the sum of all 4-digit numbers less than 2000 formed by the digits 1, 2, 3, 4 where none of the digits is repeated? See, firstly we have to form 4-digit numbers. So we have 1, 2, 3, 4. All of them are out of 1, 2, 3 and 4. And none of the digit is repeated, that is also given. So what number could be there at thousands place? Because this number is less than 2000, you cannot have 2, 3 or 4 here. Because if you have 2, 3, 4, number would be greater than 2000. So here only one can come. Once you have fixed 1 here, you just have to see how many possibilities are there. So you just fixed 1 here. You can have 2, 3, 4. Fix 1, fix 2, 4, 3. Fine. 1, fix 3. Then you have 2, 4. 1, fix 3, 4, 2. 1, fix 4, 2, 3. 1, 4, 3, 2. That is all. You just have to add now. During addition also you can use some symmetric elements. Like here, let us see. We have 2 plus 3 plus. There is some repetition or not? No. So here you have 2 plus 3 plus 4, 2 plus 3 plus 4. You have 2 plus 3 plus 4 2 times, right? So 2 plus 3 plus 4 is 9. 9 plus 9, 18. Again 9 plus 9, 18 plus 1, 19. 18 plus 1, 19. And here you have 7. Simply addition you had to do. It was not at all a challenging question. You just had to fix 1 because the number had to be less than 2000. Okay. The question was simply from the addition chapter. Now again, very simple question. From basic addition, how do we add 2 3-digit number? That was the concept that was used. Let us see. We have a 3-digit number ABC and another 3-digit number DEF. We are adding it to get 1111. So we have ABC plus DEF. Addition we are getting 1111. Right? It is given that all of them are non-zero. It is given that all of them are distinct. So if all of them are non-zero, so C and F are non-zero, and their addition, when you add C plus F, that is how we add. Units place we add first. So if you add C plus F, you are getting 1. So C plus F has to be 11 because both of them are non-zero. It cannot be 1 because for 1 you should have 0 1 here, but 0 is not allowed. So C plus F has to be 11. That is one fact that we have. C plus F has to be 11. So we have from 11 units place is 1 and 1 would be carried forward. That is how we add. And again now B plus E plus 1 again has to be 1. This one also has to come from 11 because B and E are non-zero. Otherwise if B and E are both 0, then only 1 will get here. Because it is not B and E, B plus E plus 1 has to be 11. So B plus E has to be 10. And because this is 11, 1 is again carried forward. And A plus D plus 1 is again 11. So a plus d also has to be 10. If you add all of them, you get a plus b plus c plus d plus e plus f is equal to 10 plus 10, 20 plus 11, 31. That is the answer. This question was simply from the addition chapter. You just had to know how do we add two 3-digit numbers. You add first units place, then tens place, then hundreds place using 1 carried forward. And because all of them are non-zero, these additions have to be 11 and 10. Let us see the next question. I hope you can appreciate how simply we can solve these questions, and we are not using any fancy formulas or any complicated concepts that we may not have studied in our schools. This is very much doable. Just you need to have calm mind and right approach. Now let us see this question. We have a 3-digit number, and on multiplying with d, we are getting 37dd, where a, b, c, d are different and non-zero digits. And question is, what is the value of a plus b plus c? So we have 3-digit number a, b, c. We are multiplying by d to get 37 dd, right? Fine. So what can we infer from here? This 37dd you can write as 37dd is equal to 3700 plus 10d plus d, right? Place values, and you can see a, b, c into d is equal to 3700 plus, this is 10 plus 11, 10 plus 1 is 11d. So ABC is equal to 3700 divided by d plus 11, right? That is what we got. Now this ABC is a 3-digit number, and we are having ABC is equal to 3700 divided by d plus 11. So this is an integer, this is integer, so this has to be an integer, this cannot be a fraction. So 3700 d should divide 3700. So if you factorize 3700, no, we don't even need to factorize, you just have to see what are the possibilities for d. D is a single digit, by the way. D can be 1, D can be 2, D cannot be 3, 3700 is not divisible by 3. D can be 4, yes. D can be 5, yes. Can D be 6? No. Can D be 7? No. No, right? Right, no. Can D be 8? No. Can D be 9? No. Can D be 10? Yeah. No, because D is a single digit. So these are only 4 possibilities for D, right? That is, these are the only 4 possibilities for D. Now again, if D is 1, then you will have ABC is equal to 3700 plus 11, which is 3711. But ABC is a 3-digit number, so 1 is not possible. D cannot be equal to 1. Can D be equal to 2? If D is 2, then you have again a 4-digit number here, 3700 divided by 2. That would be 1850 plus 11, so 1861. And ABC is a 3-digit number. Again, D cannot be equal to 2. Can D be equal to 4? You divide by 4. What do we get? 925 plus 11. You have 936. That is one alternative. That is okay. All of the digits are different. And if we put D is equal to 5, then what do we get? D is equal to 4, you get 936, and for D is equal to 5, you get 740 plus 11, which is 751. So these are the alternatives that we have for ABC. Fine. Right. So A plus B plus C can be 13 or it can be 18. Just to ensure that we are not making any errors, you can put back it. So if ABC is 751, you can multiply it by D. D is 5 here. So you get 3755, and if D is 936 and you multiply it by 4, both the cases we can get answer, but in this case A plus B is 18. In this case A plus B plus C is 13. So we cannot be determined because there are multiple possible answers. Even though there is 18 in the options, you cannot determine the answer. That is the thing. Now which concept we used? We just used multiplication. Fine. There was nothing else that we used. Next question. Now we have, these are 2-digit numbers where PQR is P less than Q less than R and PP plus QQ plus RR is equal to TT0. It is a 3-digit number ending with 0, that is given. Again there are 2 sub questions, so you have to solve for two questions in this one question. Now let us first see, because this is a addition of 3 2-digit numbers, can we have T is equal to 3? So can addition of 3 2-digit numbers be more than 300? Never possible, because even if all of them are 99, then also you can get maximum 297, which is less than 300 or 330. So all we can have is P can be 1 or 2. So PP plus QQ plus RR can be 110 or PP plus QQ plus RR can be 220. That is the only possibilities. Fine. Okay. Now we have to solve for, we have to see what possibilities are there in this for P and for Q. So can we have P is equal to 1? Can we have P is equal to 1? If P is equal to 1, then this is 11, then QQ plus RR is 99. If P is equal to 1, then QQ plus RR is equal to 99, and for this Q can be equal to 2, then R is equal to 7. If Q is equal to 3, then R is equal to 6. If Q is equal to 4, then R is equal to 5. So for P is equal to 1, we have 3 possible values of Q, 3 possible values of R, right? Because P and Q and R are greater than P. So this because Q is less than R, this particular case we have to reject. So there are only 2 possibilities here. For P is equal to 2, what do we have? We have QQ plus RR is equal to 88. We just subtract 22 from 110. We are considering this particular case. Similarly, we have to consider this particular case. If P is 2, then we have QQ plus RR as 88. Now if Q is 3, if Q is, this is Q, this is R, if Q is 3, then R is 5. If Q is 4, then R is also 4, but Q is less than R, so we have to reject this case. Okay. Next case, can P be equal to, if P is equal to 3, then we have QQ plus RR is equal to 77. We are subtracting 33 from 110. Then you can have Q is equal to 4, R is equal to 3. We have to reject it. So this is not possible at all because Q is less than R. So only possibilities are P is equal to 1 and P is equal to 2 for this particular thing. And here possibilities of Q are 2, 3 and 3. So for P we have 2 possibilities, for Q we have 2 possibilities. That is all. Fine. So we are done with this. Similarly, we have to check for second equation. PP plus QQ plus RR is 220. So if P is equal to 1, that we already know. P is equal to 2, that we also already know. So we'll check from P is equal to 3 and onwards because those possibilities we are already ensured. So if P is equal to 3, then we have QQ plus RR is equal to, we subtract 33 from 220 now, which will get 187, right? Now here for Q as well, we have ensured that Q is equal to 3 was possible and Q is equal to 4 was possible. So we can start with Q is equal to 5. 3 and 4 already possibilities we have confirmed. So here we will start with Q is equal to 5, then R is equal to, is it possible? We subtract 55, you don't get 2-digit number. So here we reject this. Q is equal to 6, do we get 2-digit number? No. Q is equal to 7? No. Q is equal to 8. You get R is equal to 9. That is all. Because Q is equal to 9, you will get 8 here, but that is not possible because Q is less than R. So we have another one case. For P is equal to 3 is allowed and for Q is equal to 8. So we have 3 values. Now let us take P is equal to 4 and we'll have QQ plus RR is equal to 176. Again we start with Q is equal to 3, we have checked. Q is equal to 3 and 4, that is ensured there. So Q is equal to 5, let us check. Q is equal to 5, we'll get 3-digit number. Q is equal to 6, we'll get 3-digit number. So we have to have Q is equal to 7 and then we'll get R is equal to 9. So that is another value of Q that we have. And Q is equal to 8, that is already ensured. Q is equal to 9 is not possible because R has to be R has to be greater than Q. So Q now 9 leke koi fayda nahi hai. So we have another value of Q and another value of P. Now we have 4 of each. And next we come to P is equal to 4. I know this is tiring, but let us just see that there is no complicated concept that is used. Only that questions are lengthy. In examination condition, you may not want to attempt this question because it already has 2 sub questions in it. And you can see that it requires a lot of time to actually come to a right answer. Q is equal to 5, then you will have QQ plus RR is equal to, we can subtract 55 from 220 and you will get 165. Now again we have ensured Q is equal to 3, 4 here, but with 5 you will get 3-digit number for R. That is not true. For Q is equal to 6, you will get R is equal to 9. For Q is equal to 7, that is already there. Q is equal to 8 is already there. Q is equal to 9 is not possible. So another value of Q we have arrived and P is here. So So we have five values of Q and 5 values of P. Now if we have P is equal to 6, we'll get contradiction here. Then you'll have QQ plus RR is equal to 154. And here again we start with 2 and 3, we already have valid Qs. So you can have for Q is equal to 3 and 4 there was validity. Q is equal to 5, you will get 9. But Q is equal to 5 is already, Q is equal to 5, you will get R is equal to 9. But this is not allowed because Q has to be more than P. So this case we reject. So in ultimate analysis we have 5 values of P and 5 values of Q. So statement 1 is correct, statement 2 is not correct. I know I am going a little bit faster, and this may seem complicated thought process or a chain of thought to you, but this question was like that. It had multiple sub questions to it, and because in this class we are trying to cover all PYQs and not just selectively cover only simpler ones, just for sake of completing it, we have to ensure that every question is duly covered. And this is how it was supposed to be solved. It had lot of time. It was lot of time consuming, but conceptually it did not use much more than what we have already done in our classes, or rather in our schools. Now let us come to the simpler questions. Now there is this 9-digit number and all the digits are 1. So we have this number 111, 111, 111, and we are asked to square it, multiplied by itself. Number multiplied by itself is a square. So we are asked to square this number, and now we are asked to find out the sum of digits of the square. Now think logically. No one can ask you to find square of this number manually. So whenever UPSC asks you some questions which seems way too complicated to compute, more often than not you will be required to find some pattern to it. So let us try to find some pattern. So instead of 9 we start with one single 1. You square it, you get 1. 11, you square it, you get 1 to 1. This is final square that you may want to compute. 111 square, you get 1 2 3 2 1. Now you see the pattern. You have to go till whatever number of ones are there, and ascending order and descending order. And by that logic you can just write it as there are 9 ones. So 1 2 3 4 5 6 7 8 9, and again 8 7 6 5 4 3 2 1. There is no formula, just that we can identify that this is the question where there has to be some pattern, because nobody in their right minds will ask any student to compute square of this number manually. So you don't have to calculate manually, you just have to find the pattern, and once you find the pattern you can directly write the square, and now you can add the digits. That much you can do. Or if you are familiar with the formula of addition of 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2. So you can see that here 1 plus 8, so we have 8 into 9 by 2, and this thing is appearing twice, so into 2 and plus there is 1 9. So this is the addition which comes out as 81. Or if you don't want to use this, you can simply add the digits and addition will be 81. That is also quite doable. It will take you like 30 seconds to add all those digits. So whenever you see a question that is way too complicated to be compute, then you just know that you have to find some pattern to it. Now let us see the next question. We have two numbers, that AB and CD are 2-digit numbers. We are multiplying them, multiplying AB with CD. We get a 3-digit number DEF, and adding DEF to another 3-digit number GHI, we get this 975. we are given that all of this A, B, C, D, E, F, G, H, I are distinct. Further, we are given that E and F are 0 and 8. And we are asked what is A plus B plus C. See, this question only asks you to write down everything in terms of equations. It is not very complicated question, even though it might seem like one. It is just about addition and multiplication. Okay, we'll see how. Firstly, there are A to I, so 9 digits are there, and they are non-zero, not non-zero, 0 to 9. Just let us first write the digits 1, 2, 3, 4, 5, 4, 5, 6, 7, 8 and 9. Okay, what we have is, firstly, AB into CD is some 3-digit number, D, E and F, and also we have D, E, F plus G, H, I is 9, 7, 5. Fine. What is given? E is equal to 0 and F is equal to 8. Let us just put it. E is equal to 0 and F is equal to 8, and because we can't use it again, we cut it. So rest of the alphabets cannot be 0 or 8. Okay, so we have 8 plus I is equal to 5. Now 8 plus I is equal to 5, so this 5 has to come from 15. There is no other alternative. So I has to be 7. So I has to be 7, right? So if I is 7, you get 5 here and you get 1 carried forward. Now 1 plus 0 plus H is also 7. Now H now has to be 6. There is no other option. We are just adding. So H has to be 6. If H is 6, let us cut it. 6 plus 1, 7, and then D plus G has to be 9. That is there. D plus G is equal to 9. Now because D plus G is 9, what are the choices for D plus G? D and G. If one of them is 9, 8 is not allowed because 8 is already taken. If we have 2, we need to have 7, but 7 is already taken. If we want 3, then 6, which is already taken. So D and G cannot be 1, 2, 3. So it has to be 4 and 5, because 9 also not possible because 0 is taken. So D and G have to be 4 and 5 in some order. We don't know the order. D can be 4, G can be 5, or D can be 5, G can be 4, but they are 4 and 5. So D and G are taken by 4 and 5. Now for what remains for ABC? Only ABC remain. Only option left for ABC are 1, 2, 3. Right? Only 1, 2, 3 is there. 9 is also here, so 9 cannot be repeated. So only 1, 2, 3 remain. So A plus B plus C is 1 plus 2 plus 3, which is 6. 9 is also taken, because here there is 9. So A plus B plus C has to be 6, because those are the only 3 digits that remain. We don't care about order, what is A, what is B, what is C. Any which way, or addition would be 6. See how simply this question could have been solved. I mean, it did not require you to write any equation, did not require you to solve using any formula. It just required you to write everything in written terms in front of you and use basic, very basic concepts of multiplication and addition. It was as simple as that. If you are still confused, you can rewatch the video, or you can post in the comment section. Now this is again very simple question, which I think most of the students solved it correctly, because this was very simple. See, we are having 4 single digits, distinct single digit positive numbers. These are single digit numbers, and we just want to find out what is the greatest value of P plus Q into R plus S. So we have P plus Q into R plus S. Now logically you tell me, this PQRS, what could they be? They have to be largest numbers, because we want to maximize this particular product. So PQRS has to be 6, 7, 8, 9. We cannot take them smaller because we want to maximize the product. So PQRS has to be from these 4 values. We just want to see which of these combinations gives us maximum product. So just take the, we can take 6 7 8 9, or we can take 6 8 and 7 9, and we can take 6 9 7 8. These are the only possibilities, because even if you change the order, product won't change, additions won't change. Now if you just have to compute in these three cases, 6 plus 7, 13 into 17. In this case you have 14 into 16, and in this case you have 15 into 15. Just have to calculate these three products, and if you have mugged up all the tables till 20, it will be cakewalk for you, and you will find out that this is the maximum product, which is 225. That was the answer. All you have to do was just see which combinations are possible. Only 3 are possible, and that is why you can just calculate these 3 values and see which is the maximum. Very simple question, very doable in examination condition within 1 minute or maximum 1.5 minutes. Now let us see the next question. Very interesting one, but very simple one. No formulas again. Question is, what is the sum of all the digits? Digits matlab single digits that appear in all the integers from 10 to 100. So we have to see there are integers from 10 to 100, and we want to calculate sum of the digits. All we have to do is see which digits appear how many times. So 1 appear how many times, 2 appears how many times, 3 appears how many times, and so on till 9. So how many times does 1 appear? 1 will appear in 10, in 100, right? And where else? It will appear in 11, 12, 13 until 19. Where else it will appear? It will appear in 21, 31 till 91, and in 100 and in 10. This is where 1 will appear. So how many times? Here 9, here 9, 18 plus 19 plus 20. 20 times 1 will appear. So 1 will appear 20 times. How many times 2 will appear? Same. Instead of 11 to 19, we'll have 21 to 29, and from here 20, here 12 to 92. You have to rub these two now. So how many times? Here 9 plus 9, 18 times. So 2 will appear 18 times, right? Similarly, now you can see the symmetry. 3 instead of 2, you'll just have 3 here, this line and this line. Again 3 will appear 18 times, 4 will appear 18 times, and so on. And 9 will appear, it will also appear 18 times. Why is 1 appearing more times? Because 1 was there in 100 as well as in 10. Both the numbers are included here. That is why 1 is appearing more number of times. And now we just want to calculate addition of all these digits, right? We want to calculate 20 plus 2 into 18 plus 3 into 18 plus up to 9 into 18, which is equal to 20 plus, you can take 18 as common, you have 2 plus 3 plus up to 9, which is equal to 20 plus this. You can add these numbers, and I think you will get 44 here. 18 into 44. You can find out the answer. Answer comes out as 856. Fine. You just have to see which digit appears how many number of times in between these 10 and 100. So manually you have to see how many times. You just have to see the pattern, and once you see the pattern for 2 and 3, rest of the pattern automatically follows, and quickly you can arrive at this answer. This also was very doable in examination hall. It could have taken you 2 minutes or maximum 3 minutes, but still you could be sure that you arrived at the right answer. Again, no formula, Nothing used. All that is used is your ability to see the pattern and then add numbers, addition and multiplication, right? Nothing else was used. Now let us see the next question. This particular question, it was little bit of trial and error type of question. There is no one particular method to solve this, but you just have to apply your logic that what could be the maximum ratio. So we have a 3-digit number such that ratio of number to sum of its digits is the least. So if we have this number xyz, we want to take ratio of this number to ratio of its digits, right? Or you can write it as 100x plus 10y plus z divided by x plus y plus z. Now logically, when will this ratio be least? When denominator is maximum and at the same time numerator is minimum. So this number should be as small as possible and this number should be as large as possible. So logically you can think about it as like, so for this number to be small, you need to have x is equal to 1 because that is disproportionately increasing size of the numerator. So x has to be 1, and for again maximizing denominator now, z should be 9. So numerator you have to minimize and denominator you have to maximize, both of the things. Again, this is not very mathematical, but this is logical. You just have to use your logic and sense, little bit of intuition to arrive at the answer. So to minimize numerator, x has to be 1, and to maximize denominator, z has to be 9. So difference between those two is 8. That was it. I mean, there is no one particular method to arrive at the answer very, very mathematically. You just have to use little bit of your intuition. But you have to know these little concepts, like when we have a ratio, when the ratio is minimum, ratio would be minimum when numerator is minimum and denominator is maximum. Numerator we want to make as small as possible and denominator we want to make as large as possible. If you know this particular fact, then you can come to the right answer here. Next question is very easy. Again, something you can be we have done in class actually, this particular question, not this exact question, but this type of questions we have done many such questions. Question is in the expansion of this particular power. So we have 5, 7, 2, 4, 2 raised to 9 into 7 into 5 into 3 into 1, and we want to find out what is the units place. Now again, as a student, you must immediately come to the conclusion that nobody in their right mind would ask you to compute this power. So there would be some pattern to it, and the pattern is that these digits, these numbers are irrelevant when it comes to units place. All that matters is this 2. So this power would follow whatever the power of 2 would follow as a pattern, and that comes from a fact that we are when we are taking power, we are just multiplying same number again and again and again. So units place would be 2 into 2 into 2 into 2, and all these numbers are irrelevant. So because we are anyway multiplying only 2 as a units place for units place calculation, powers would follow just powers of 2. If you want detailed explanation of this, we can discuss it sometime later, but for now let us just consider it as a fact that this for calculating units place of this particular power, all these digits are irrelevant and it will only be same as powers of 2. So we'll just rub it, because anyway that doesn't matter. So we just want to calculate units place of this particular power, and we have seen that powers of 2, 2 raised to 1 units place is 2, 2 raised to 2 units place is 4, 2 raised to 3 units place is 8, 2 raised to 4 units place is 16 ka 6, 2 raised to 5 again we have 32 ka 2. So this particular pattern 2, 4, 8, 6 is repeated for powers of 2. So all we want to see is where does this particular product lie when we are taking powers of 2. Powers of 2 come in the blocks of 4. So when we divide this particular number by 4. If the remainder is 1, units place is 4. If the remainder is 2, it is 4. If remainder is 3, then 8, and if remainder is 0, units place is 6. Now you can see that this particular number, you can calculate the number we have, it is 2 raised to 945, and if you divide this 945 by 4, we can see that this is 944 plus 1. 944 is divisible by 4, so remainder is 1, so units place is 2. That is the answer. Right, units place is 2, so that is the answer. Fine. We will discuss this in very detail in our classroom program, which you are welcome to join. But as a fact, you can consider this as whenever we are finding out units place of these kind of powers, only digit at the units place would determine the pattern, not other digits. For this could have been any number like 57242 raised to some power, here it is there, no? So it could have been 123 raised to some 1232 raised to same power, and units place would be same. Similarly, question next year could be 57243 raised to this 9 into 5 into. Again, only 3 raised to that particular power would determine the units place and not these digits. And to calculate that, again you have to find out the pattern which 3 key powers follow. It is also in the brackets of 4. Then you have to see what is the remainder when you divide that particular number by 4, and that remainder would be guiding the units place. Again, I know I am going a little bit faster and everything may not be clear, but it is very standard question which have been asked in earlier times as well, the units place of powers. Now this is again, it seems like concept from like maybe patterns, maybe puzzle, maybe from series, but no, it is topic, this question from arithmetic. How? Question is, we have to choose a group which is different from others, and if you know there are something called as prime numbers, and if you know the prime numbers from 1 to 100, you can immediately see that all of these are prime numbers except this 91, which is 7 into 13. So this is the odd man out. Rest of all the numbers are prime numbers. So this question actually is from the arithmetic topic, and if you are aware about the prime numbers, and if you have mugged up or all the prime numbers from 0 to 100 or 1 to 100, which I recommend, you can immediately see the answer in front of your eyes. No need to even put pen to paper. You can just simply mark the correct answer. This question is again kind of repetition, I would say, because similar questions have was asked in last year's paper as well. We are given one prime number and one composite number. Now to solve this question, you should know what the prime number is and what the composite number is. Without that, you cannot proceed. So see how much arithmetic holds importance. And yes, firstly the question is can be. So anyway, because the statement is can be, maximum possibility is that these statements are correct. But what we need to do in such questions is that we need to just put values. We need to know initial few prime numbers, and composite numbers we anyway know. But if you know initial few prime numbers, you can just play around with it a little bit and you can find out the answer. Now firstly, let's see this statement. This statement was directly from last year's paper. Last year 2022 paper, there was same statement, no difference, same statement as it is. Prime into composite number can be odd. When can be multiplication of two numbers odd? When both of them are odd. Can we have odd prime number? Yes, like 3, 5, 7, so many. Can we have odd composite number? Yes, 9, 15, so many. So this is definitely true. We can have both odd numbers. 2p plus c can be odd. When is addition of two numbers odd? When one is even, one is odd. So this is even, 2 into p. Can c be odd? Can we have odd composite number? Yes, there are many like 9, 15 as I already said. So this is also correct, this is also correct. And for this, you just have to play around with a little bit, and this also comes out to be true. Like you can take 11 as prime number p and 9 as composite. You can have 11 plus 9, 11 minus 9 is equal to 20 by 2 equal to 10, which is a even number. So it is also true. Not very difficult question, although it seems like three-part question. All statements are very elementary, and just playing around with few values, you will get the answer. Again, kind of repeated question from the topic of divisions. We want to find out what is the remainder when this particular number is divided by 100. Now we know that this is a dividend, this is divisor, and whenever we divide this number by divisor, we get some quotient and some remainder, and if the remainder is 0, we say that this number is totally divisible by 100. Conversely, if this number is divisible by divisor, then the remainder is 0. And now for this particular thing, we just try to divide by 100. 100 you can write as 2 square into 5 square. It's prime factorization. And 2 square is 4, which gets cut here. Here you have 24. That doesn't matter, but it is completely divisible. And 5 square, 1 5 will get cut from here. Another 5 will get cut from here. So this 100 in fact completely divides above number. So this number is completely divisible by 100. So by definition, the remainder has to be 0. Another trick you can say, or shortcut you can say, if you don't have any time in examination hall, wherever UPSC has asked this kind of questions, remainder has always been 0, because they cannot expect students to actually divide it manually in examination hall, right? There is one exception, although I must mention this has been true for most cases except once, when UPSC asked students to divide by 100 and remainder was not 0 but 50. But so this was the honorable mention, so beware about it. You need to actually study this topic of remainders to get the answers with confidence. But in this particular case, remainder was of course 0, because this number is completely divisible by 100. Coming to next question, you have, this is again, I think this is the last question from 2023 from arithmetic. We have three traffic signals. This is from LCM topic, by the way. Each signal changes color from green to red and then from red to green. First signal takes 25 seconds, second 39 seconds, and third takes 60 seconds to change the color from green to red. Duration for colors are same. At 2 p.m. they together turn green, and what time will they change to green next simultaneously? Now what is happening? Simply, there is one signal. There are three colors: red, green and yellow. Now green, the signal turns red, green and yellow together at 2 p.m. Now again after 25 seconds signal will turn green. There is some common duration for which they remain lighted, and after 25 seconds it will turn green. After 39 yellow will again turn yellow, and after what number is given, 60 seconds red will again turn red. So whenever we want to find out after how much time it will again happen together, we invariably are talking about least common multiple of these three numbers. Least common multiple of these three numbers. And I don't know if you are aware, if you know how to calculate LCM, but let us see. We can take 25 as equal to prime factorization 5 square. You have 39, which is 3 into 13, and you have 60, which is 2 square into 3 into 5. This is the prime factorization. And what is LCM? LCM is equal to, we take maximum power of 2, which is 2 square, maximum power of 3, which is 3, maximum power of 5, which is 5 square, and maximum power of 13, which is 13. This is the LCM, right? You can calculate the LCM. This is in seconds, by the way. Everything is given in seconds. You can directly convert it in minutes. How do we convert it in minutes? 2 square into 3 into 5 square into 13 divided by 60. This is how we convert second into minutes. So what do we have here? 2 square into 3 into 5, you can cut. So we have 65. Okay. So after 65 minutes, again they will together turn green. Here 65 plus 65 minutes we are talking about. So after 65 minutes, but that is not in the option. So we get to next common multiple, which is 130. 130 would be 2 hours 10 minutes. So after 2 p.m. 2 hours 10 minutes is 4:10 p.m. That would be the answer. We have to calculate LCM and see which common multiple is there in the options. Now this is what I was telling you. This is 2022 question. Exactly same question from this year's question. First statement is same. You can see P into Q is odd number. Here P is a prime number, Q is a composite number. Can it be odd number? Yes, we have just seen. Q by P, can it be prime number? Yes, I mean you can take as 4 and 2, or you can take any for that matter, P square and P. P square is a composite number, P is a prime number, division is P, which is prime number. So yes, can P plus Q be prime number? Again take any example like 2 plus 3, 5. All statements are correct. But if this statement said that P plus Q can be prime number if both of them are, if P is not 2, 2 is the smallest prime number. So if P is not the smallest prime number, something like that, if the statement said, it means that 3 is a odd number. Then also you can have, because Q can be even, right? So odd plus even, you can have odd number, no issues. So basically you have to play around with these statements. You can have initial few prime numbers, initial few composite number, you can put the values, or directly you can solve using basic properties if you know them. See the same question which was there earlier, here also remainder is 0 when we divide this number by 1261. But here the catch is, if you want to solve it with confidence, we have to know the prime factorization of 1261. And how do we check it? We just have to keep dividing this number by prime numbers till we get the proper division. So if we have to check by 2, it is not divisible. 3, no. 5, no. 7, no. 13, 7, no. 11, no. But by 13 it is divisible. So you get it is as 13 into 97. So you have to check till 13. That is the challenge in this particular question. So you have to know table of 13. That is the challenge. But once you get this, you just have to divide. 97 will directly cancel, and 13 7s are 91. So complete divisibility we have. So remainder has to be 0. Again, very simple question from 2022 paper. We are given this product and we want to see that what is the maximum value of m. We are writing this particular product in the form of 3 raised to m into n, where m is the maximum possible value. So basically what the question asks us, how many times 3 appears in this particular product maximum. We can see where does 3 appear. 3 will appear here once as 3, then it will appear in 6, then in 9, then in 12, and then in 15. That is where 3 will appear. Here it will appear once, here twice, here once, and here once. Total it will appear 6 times. Answer is simply 6. Fine. Very simple question, last year's question. So you can see that how important prime factorization is. Back to back there have been 2 questions in 2022 and there are some questions asked in 23 as well. Now again this is the question of again prime factorization. We are having 2-digit numbers and one is, and they are like xy and yx, that is given. Okay, and their product is given as p into q is equal to 2430. We can just try to factorize this prime factorization of this particular number. So let us try to divide it by, it is divisible by 9, that we can see. So let us divide it by 9. So it is 9 into 270, which is equal to, again this is, 243 is 3 raised to 5 anyway. So 3 raised to 5 into 2 into 5, that is the prime factorization. Now let us just write it in the expanded way. 2 into 3 into, and now we want it to be, it is just product of two numbers p into q. So this multiplication we just have to split into two groups. One group would be p, one group would be q, and p and q has to be like x, y, y, x. So you just check, can it be this? No, this is just a single digit number, so that is not allowed. We want both of them to be two digit number. Can it be this? This is 9 into this 5 into 3 15, 15 into 3 45 into 3. This is a 3 digit number, but we need both of them to be 2 digit number, so that is not it. Can it be this? We have 5 into 9 45, this is 54. Yes, x, y, y, x, 45 54. We got our x, y and y x. What is the difference between p and q? Difference between these two is 9. That is how you could solve it. Very simply, just have to find the prime factorization and then play around with it a little bit to get the right answer. I think this is the last question for the day. What is the smallest number greater than 1000 that when divided by one of these numbers leaves remainder of 3? Basically, there is particular number and we try to divide that number by these numbers, and always we have remainder as 3. So this particular number, whenever we try to divide it by, let us say 6q plus 3, x is equal to 9 q1, let us say this is q2 plus 3, is equal to 12 q3 plus 3, and so on. So basically, if we divide, if we take x that side, we have x minus 3 is equal to 6 into q1, x minus 3 is equal to 9 q2 is equal to 12 q3 is equal to 15 q4 is equal to 18 q5. So this number x minus 3 is divisible by 6, 9, 12, 15, 18, all of them. So we have a number which is divisible by all of these numbers. So we have a number that is common multiple of all of these numbers. Because this number is divisible by all of these numbers, it is a multiple of all of these numbers. And because it is of all of these numbers, it is a common multiple of all of these numbers. Where have we heard this term common multiple? In LCM, least common multiple, which we can easily find. Now this is exercise for you. What is the LCM of these numbers? It turns out as 180. 180 is LCM of all of these numbers. But it is, so 180 is this x minus 3. So x would be 180 plus 3, 183. But we want number to be greater than 1000. This is not greater than 1000, 183. So we take multiples of 180 till we get number greater than 1000. We can have 360, 540, 720, 900. Still 903 is not greater than 1000. But next number is 1080. This is greater than 1000, which is x minus 3. So x kitna ho gaya? X minus 3 is equal to 1080. So x is equal to 1083. This is again one of the standard questions that was asked earlier as well. This was in 2022 as well. It was repeated. It is from LCM chapter. Very simple question. Once you realize that, all you have to do is find the LCM and take common multiple till we get number greater than 1000, because every common multiple would be multiple of LCM, least common multiple. LCM is the least of all the common multiples, and all the common multiples are in fact multiples of LCM as well. So this was it. This was the first of arithmetic PYQs. From arithmetic there have been large number of PYQs, that is why it will take some time. We'll take 3 lectures for it. I hope it was helpful. If you find it useful, then you can comment, and if you have any doubt, then also you can comment. If you want me to change anything, then also you can comment. If you want me to continue, let me know. And if you want detailed explanation of all these things and all the concepts behind it, please check out our foundation CSAT foundation batch, ACE CSAT, that we are launching from 20th of October. Initial few lectures you can just come and sit for demo if you want, but this is how we'll cover stuff, that we'll not really focus on many formulas. We will focus on foundational concepts because that is where UPSC is clearly focusing on. Thank you, and we'll meet tomorrow.